So, welcome to my walkthrough for the Edexcel Higher. It's the GCSE and it's January 2019 and this is paper 1R. So let's go. So although they're all calculator allowed, they do like these show questions. So here we go. Show means do, so just crack on and show full working out. So let's turn them both into improper, top heavy, whatever you call them. So leave the bottoms the same. And I just do big times bottom plus top. Big times bottom is 8, plus the top is 11, and I do that before converting. So we'll make them all over 12. That's the LCM of 3 and 4. We quadruple the bottom, do the same to the top, but we treble the bottom on the right. We treble the top. At that stage, you only add the numerators. 58. No, don't think so. 53. And how many 12s go into 53? It's a 4 with a remainder of 5. And you are done and dusted. So for number 2, typical wordy, ratio, and mixed in with a bit of fractions. So lots of ways you can go about this. Order doesn't really matter. I went for, well, if there's 60 children, let's look at how many of those are girls. Well, 3/4, because 3 out of 4 are girls, and 3/5 of those play an instrument. My calc says 27. I then move to the boys. 1/4 are boys. 4/5 of the lads play an instrument, and that gives us 12 who play. So total who play is 39, and what fraction out of 60? So your choice, 39 over 60, or 13/20. On we go. So number 3. As you can see, back-to-back triangles, so your first suspicion is normally some form of Pythag or SOHCAHTOA, and there's no angles, so it's Pythagoras. So work out the length of P to Q. I always like to stick an X on what I'm after. So the only way I can get X is if I know something else about the triangle it's on. And there's the connection. It'd be nice to know what QS was worth, and we definitely have enough information for QS. So QS squared will be the hypotenuse squared minus the adjacent, or one of the other smaller sides squared. It's not necessarily the adjacent, is it? And that'll be 196 minus 100, so that'll be the root of 96. Or in other words, 4√6 if you've pressed a calc. To find x, because we're now on to phase 2, we're now on to the left-hand side, x is on the hypotenuse, so we can say that x is the square root of these two sides squared and added. So 5 squared, which is 25, and 4√6 squared, because we didn't really need to. Not square root it, we could have left it as 96, because it gives us a lovely 121. Nice square number. So we square root it to get the answer of 11. Number 4, one of those mystery number questions. 4 blanks. A is the least, 40 is the greatest. The range is 14, so the lowest must be 40 minus 14, 26, and there's 2 of them. The median, so the median will be halfway between these 2 numbers. So if the median is 30, that's 4 above, so we need to go 4 above again. That'll be 34 for your 3 marks. Next one. So we've got one of those weird situations now. Be careful. It's minutes there. It's hours there. So always think about what fraction. So every minute is 1/60th of an hour. So when you get this question, yep, it's a distance, speed, time question. That bit's a bit more obvious. And to get speed, we need to do distance divided by time, but that time needs to be in hours. Okay, so we're going to do it as 8/60ths of an hour. Stick all that in your calculator and the calc does the heavy lifting. 228.75. Job done. Number 6. So whenever you see a question like this, just go back to basics. Think what you've seen year 7. What do you know about an isosceles triangle? Base angles are the same. So we can make the statement that whatever 3x plus 10 is, it's the same as x plus 52. You've set your equation up. Now solve it. So take away x from both sides. Take away 10 from both sides. I'm getting x to be 21, but you're not yet close to the right answer. You're closer though. So x is 21. So how big are each of these angles? Well, you need to treble it and add 10, or just add 52. Because if your 21's right, you should get the same answer. So they're both 73. In other words, they total 146. So your final job is 180 minus 146, and you finish up with a 34. Number 7. Gotta admit, very overcomplicated in my opinion. Very much the old sledgehammer to crack a walnut here. You just want what the heck is the scale factor. Now, if it was like 4/2, you'd do 4 divided by 2. So your scale factor is 2. If you're getting bigger or smaller, you either times by 2 or divide by 2. So at the end of the day, just divide your numbers. Whichever way round you get them depends on whichever way round you want them, really. So I just say that my scale factor is 147 over 187, because that number is less than 1. Because my multiplier that way, it's getting smaller. So I prefer to have my multiplier to be less than 1. So the height of Tower A on a scale model is 90. So my multiplier is there on your calcs. Yep, it's as easy as 90 multiplied by your multiplier. But obviously you could be dividing by 187 over 147 if you'd done it or thought about it that way round. They all lead to nearest centimetre. I get 70.748 and so on. In other words, 71 centimetres to the nearest integer. Good old simultaneous equations, one of the basic ones. You could double the top equation. You could quadruple the bottom equation. That's entirely up to you. I've gone for doubling the top equation. So I get 8x plus 4y equals 18. So I'm now kind of moved on from that one. So the numbers in front of the y's are both 4, but one's a plus and one's a minus. Different signs. That's add. So we get 9x equals 27. So x is 3. Once you've got that banked, pick one of your 2 original equations. I'll pick the bottom one. I'll replace x with 3. Add 4y to both sides. Subtract 9 from both sides. And now divide both sides by 4. Give it a fraction or a decimal. I'll go for minus 1.5. It's all good. Next. So Kind of HCF LCM kind of question, but with standard form mixed in. So write it in standard form, so don't forget, we want a number between 1 and 10. And to do that, we've had to divide it by 10 twice. So to balance it up, we multiply the 10 to the power of 9 twice, and we'll get 10 to the power of 11. Now the next bit, write it in as a powers of prime factors. So let's just think about the fact that it'll be 48 we need to deconstruct, which would be 10 to the power of 10. One above that, one below that, because it's in between. So let's focus on the 48. That's 4 12s. 4 is 2, that's prime. 2, that's prime. And we've got 3 times 2 times 2. It's been decomposed. But then think about your 10 to the power of 10. Don't forget, the number 10 is 5 2s. That's 5 2s in prime factor form. So if you did that to all of the 10s, you'd have 10 5s and 10 2s. Or in other words, you'd have 5 to the power of 10 and 2 to the power of 10. But as you can see, there's some other stuff we need to bring into play. So there's no extra 5s. There's 1 extra 3. But there's 4 extra 2s. So you need to add 4 to the power of the 2. And we get 2 to the power of 14. Find the largest factor that is odd. So as you know, whenever you times by an even number, you get an even answer. So basically, you need to miss the even numbers. So it's 5 to the power of 10 multiplied by 3. Stick it in your calc, you get the wonderful answer of 29,296,875. On we go. Number 10. So it's basically part of a circle. It's finding areas and perimeters. So don't forget pi r squared and 2 pi r will be your main focus. But before you start attacking that, they've given us the diameter. So the large radius is 6 and the small internal radius is 4. And now we treat it like a semicircle minus a semicircle. That's all we do. The area of the shape will be the large semicircle minus the small semicircle. Now it wants the answer as a multiple of pi, so I'm going to leave pi out of it. So it's, as we know, area of a shape is pi r squared, so we're just really now focused on the r squared parts, but they're semicircles, so it's r squared halved. So we've got 6 squared halved minus the smaller semicircle, which is 4 squared halved. And obviously you didn't have to show that bit, I'm just explaining it. You could have just gone straight to 18 minus what we got, 16 over 2 is 8. So our final answer will just be 10 pi centimetres squared, which is down here somewhere, but there we go. Number 11. So the old mean question where they give you the means, so the main part of it is it's all about the totals. So 12 boys, 8 girls, straight away 20 students. The mean of the boys, so let's focus on the boys. 12 of them, lots of 5.5, meaning the lads account for 66 of the coins. The girls, we already know how many coins they've got, so actually there's no work to be done there. We can just move on to finding the total. there's 84 coins belonging to members of this class, and we need to divide it by the 20 students. So you either get 21 fifths, 4 and a fifth, or 4.2. On we go. So when it comes to nth term of fractions, just look at what's going on top. So on top, it goes up by 1. It's just the integers themselves. So on the top, it's just n. So n's going to be part of your answer. Your focus needs to be what's the nth term of the bottom. Well, it's going up in 2s. That tells you there is a 2n aspect to it. And now you look at your 2 times table. As you can see, what do we do to our 2 times table to get the numbers on the bottom, the denominators? We subtract 1. And there we go. Part B. So it relies on that bit of knowledge that is easy to forget. So remember that all even numbers look like that. No matter what n is, as long as n's an integer, obviously, no matter what n is, if n's an integer, 2n is even. So an odd number is 2n plus 1. And obviously it could be 2n minus 1, could be 2n plus 19. Who cares? They're all going to have the same kind of result. So when we square it, that's really the crux of this question. They want you to expand those brackets. So let's do it. Square the first, square the last, times the 2 together and double it. And the key bit, take the 4 out. So as long as n's an integer, you've essentially got there, you've got a multiple of 4. That's what that is. Should have done that. And there, that will be your remainder. Okay, that's why I prefer to stick with the plus 1 rather than any other nonsense. Why would you use bigger numbers than you need? So you just need a little bit of sentence at the end to say by taking the 4 out, you have a multiple of 4 and a remainder of 1. Next, bit of differentiation. So don't forget, it's easier than you think. It's just not enough room with my giant jumbo pen here. Bring the power down. Take 1 off the power. Bring the power down. Take 1 off the power. Negative 8x just means ignore the x on the end. And the plus 12 disappears. On we go. So work out the coordinates of the 2 turning points. Now, turning points is another name for maximum and minimum. And the key bit that happens at a max or a min is that the gradient, in other words, the gradient function equals 0. So whatever you got for part A, stick it equal to 0 and solve it. So obviously quadratic formula is potential, but the numbers are reasonably small. So I preferred to do it by sight because you need 3x and x. 3 is a prime number, so limited options. And obviously it's either a 4 and a 2 or an 8 and a 1. How do we get minus 2x? It's plus 4x in there, minus 6x there. Or obviously, you could have spent a bit longer doing the AC method. It's all good. And that gives you the 2. It only wants the x coordinates. So x equals negative 4/3 and x equals 2. One's a max, one's a min. Show that the x-axis is a tangent to the curve C. So don't forget, to be a tangent, it would be a max or a min point at that point. So the idea here is take either of these values and substitute them into your original equation and hope that at least one of them ends up being 0. you'll get nowhere with that one. Plus, you wouldn't pick it anyway, because you should always pick the easiest first. So I'm going to sub in x equals 2. So let the examiner know what you're doing. So when x equals 2, y equals 2 cubed minus 2 squared minus 8 twos plus 12, and you do indeed get 0. And then you can write the old lover, hence the coordinate 2, 0 is a turning point, like so. In other words, is a tangent. So write yourself a little sentence there. As always, I've done it in proper examiner's terms on my worked answers on the website. Number 14, for accuracy purposes, because me and this E-pen, they are rubbish. It's like using a crayon, so I've given up on that. So I've just cut and pasted from my worked answers. So part A, find an estimate, 80,000 euros or less. So that's why you find the 80,000, you track it up, and you go across. Mine goes up slightly, my line. I should be getting 97, 96 or something. Doesn't matter. I'm going to give 97 because the mark scheme allows 96 to 98 anyway. I'll not scroll down. I'll stay on this page. The next page gives you the values required to plot. I would always, if given the choice, always use straight lines. So that's part B done. And part C says find an estimate for the median. So for the change in the median. So your median for 120 will be at 60, and you need to go along to both the line you're given and the one you've drawn. Wherever they cross, zoom down to the x-axis and take your readings off there. I got 68 and 15. So to find the difference, or in other words, the increase, we took them away. Mark scheme allows 13 to 15. So I'm at the lower end, but I'm fine. On we go. So we've got some laws of indices. So as always with these, one thing at a time. Do 3 to the power of 4. Calc if you need to. Mental arithmetic's fine. Then when you've got a power to a power, that's when you multiply the powers. So 2 times 4 means we have x to the power of 8, and 5 fours are 20, so we have 5 fours are 20, so we have y to the power of 20. Part B, you can do these in any order. Put your line there, do 4n times the first bracket. I always prefer to do brackets first, so I left the 4n alone. Expand the brackets. So n squared minus 15. Now we do the n terms, so minus 3n plus 5n means positive 2n when simplified, and now I just expand the brackets. So they give me 4n cubed, that is 8n, and that minus 60n. On we go. Now C is a disguised difference of 2 squares. So please don't forget, it's one of them where essentially they normally look like that. And it factorizes to x plus 5 and x minus 5 because it's a weird looking square thing minus square thing. Now the less obvious clue is it's only worth 1 mark. All right, so that's one of the clues to prod you into it being difference of 2 squares. So the square root of 4c squared is 2c. It's always plus and minus. And 9d squared, sorry, minus 9, becomes plus and minus 3d. So yeah, one of them disguised ones. Now part D is also a little weird one. I'm going to factorise the bottom first so that I can illustrate something. Take out an x, and you're left with 4 minus x. Now what's going on the top looks pretty standard. It's just x minus 4 and x minus 3. But although they look the same, they're not quite the same. So how can we get them to cancel? Clever bit is, you can just flip both of these around, but I'll explain why, because it's important to know why. What have I done between there and there? Essentially, I've taken out a minus 1 from the first bracket. So that means the x and the minus 4 change signs. I've also taken a minus out of the second brackets, which is why the 3 and the x have also changed signs. Plus becomes minus, minus becomes plus. And so essentially what's happened is I've taken out 2 minuses, which is why they're the same damn thing. And if you expand the brackets, if you times these brackets out, see what you get. You still actually get x squared minus 7x plus 12. But now they cancel and you get the correct answer of 3 minus x over x instead of having a potential of x minus 3 on top, which ain't correct. Number 16. Good old probability trees, but don't draw the probability trees. No point. Just remember that when you go down branches, it's multiply, and if you need more than one branch, it's add. So for this one, we've got 7, 3 and 2, so 12 in total, so we're going to be fractions of 12 to begin with. So Lucy takes a bead, probability she gets a yellow is 2/12, but she keeps it. So that means there's 11 left and only 1 yellow. Get them multiplied, it's 2 over 132. But if you're using a calc, it'll cancel down to 1 over 66. Now part B, there's a couple of ways of going about this. I think the slightly longer way is just to take it as red. Just do not the same colour. Just go red, green and double it. Just go green, yellow and all that. I prefer to go not the same colour means 1 minus the same. And the reason I think it's easier is we've already done one of them. We've already done yellow, yellow. So we can do 1 minus yellow, yellow. And then we need to take away red, red. So the probability of red, red, 7/12, 6/11, and then minus green, green, that's 3/12 multiplied by 2/11. That's when you get handy on your calculator, stick it all in, and I get 41 over 66 for the 3 marks. Number 17. So as you can see, one of them questions where there's not enough numbers given. So don't get put off by these. When there are not enough numbers, you can usually rest on the idea that a lot of the R's will just cancel. The R's might as well not be there, just call it 1 and 2 or whatever, because R's are going to disappear and so on. Lots of stuff cancels. Let's just see what happens, but do not get put off, because at the end of the day, you've got the formula on your formula page for the sphere and the cylinder. Dead easy, it's a circle times the height. So, total surface area of a cylinder is the curved surface area. I know that's a rectangle, but that's the curved bit, because when you take the label off a soup or bean tin, it will be a rectangular shape, and the area of that will be 2r is its height, and the distance along there will actually be the circumference of that circle, which is 2 pi r. But then you've also got the circular top and the circular bottom. So let's just do it. So the rectangle is 2r times 2 pi r, and the two circles, they're both the same, so we just do 2 lots of pi times the radius is r, so it's just r squared. What the heck have we got going on here? Well, that gives us 4 r squared pi plus 2 r squared pi, and it wants it in terms of r, and we can just simplify them together. There's 6r squareds pi, and if you want to stick a centimetre squared, who cares? So I'm just going to read you. So the next bit, all right, does go into total surface area and total volume. So do make sure you flick back for your formulas for that. But the key really is, again, radius is r in all circumstances. So do not let the words put you off, because you've already done that bit. So surface area of the cylinder to surface area of the sphere. Well, you should have flicked back to your formula page, because the sphere is 4 times pi times the radius squared. Well, let's just stick all that in and see what happens. So we've got 6 pi r squared for our previous answer. We've got 4 pi r squared from our formula page. And like I said originally at the start, everything cancels. Divide both sides by r squared, divide both sides by pi, we're just left with 6 to 4. Or in other words, 3 to 2. Now let's do volume of the cylinder and volume of the sphere. So volume of a cylinder is pi times the radius squared multiplied by its height, which, as you may recall, is 2r. Volume of a sphere, again, check your formula page, it's 4/3 pi r squared. Lots of stuff cancels. Sorry, 4/3 pi r cubed. Lots of stuff cancels. The pi's are gone. There's an r squared and an r, which makes r cubed. They are gone. We're only left with a 2 on the left-hand side. We're only left with 4/3 on the right-hand side. Let's get them into integers by trebling both sides. We get 6 to 4. And oh look, could have left them as 6 to 4 actually, but there we go, 3 to 2. Not straightforward, they never are when you haven't got any numbers to work with and it's all in terms of letters, but don't let that fact put you off. It was mostly picking the right formula at the right time off the formula page and hoping lots of nonsense cancels out. As you can see, it definitely did. Number 18, good old surds. Your choice as to whether you simplify the root 8 now, because it can be simplified. Feel free to check your calc, it's 2√2. All right, or do it later. I'll do it later. So I'm going to multiply by the conjugate. In other words, I will change the sign to a plus. So top times top, root 8 times root 8 gives me 8. And it gives me 2√8. As I say, I'll transfer that into root 2 form in a sec. On the bottom, you only do root 8 times root 8 and 2 times negative 2, because don't forget, the rest cancels, the negative 2 root 8 and positive 2 root 8. So now let's tidy it up. On the bottom, I've got 4. On the top, I've got an 8. But here, I've got 2 lots of root 8. That's 2 lots of 2 root 2, or in other words, 4 root 2. And that's a clue for your answer. Should be the case that there's nothing on the bottom. There's no denominator. And indeed, that's what we've got. So we can be confident that 2 plus root 2 is the correct answer. Now, number 19, as always with these, when it says give a reason, I always write it out in full on my worked answers. So I've done exactly that. I've done all the alternate angles are equal, etc., etc. I've done all that on my full answers, on my worked answers. So feel free to consult that here. I just talk you through. I'm going to do a fair bit of talking here because I think this one is a difficult one to spot because there's missing lines. So I'm going to draw on. Whenever there's a tangent that's not fully drawn, I'm always suspicious. And whenever it's like just, almost looks like there's a side missing there. So let's just fill that in. So now, let's just bring up a different colour pen. I'm a bit bored with green. Let's go with that. So once you know that that is 73, you can now spot your alternate angles, because that is also 73. The other thing to spot using the 73 and the tangent is, if this angle is 73, so is that. Because don't forget, what have we got going on? We've got alternate segment theorem. We have a triangle which touches the tangent. So 73 and 73 are the same thanks to, quote, alternate segment theorem. The next bit is, now you've got a quadrilateral set up, you have a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral sum to make 180. So we know that this is 73. So in the quadrilateral, that angle there must be 107. And that means you now know enough to find DCE, because DCE is here. And DCE is 107 minus 73. It's just 34 degrees. But yeah, I think that's quite a difficult one. Not difficult circle theorem, just a difficult one to spot them. Definitely not enough lines on that diagram. Speaking of which, I've already cheated on this one, drawn the extra ones. So 3D SOHCAHTOA, find the angle between the line MA, so draw that on, and the plane ABCD. So you need this line here coming down from M. I call that N, believe it or not, so does the mark scheme. So your starting point is, we don't know any lengths. It's a cube. You could make it up. You could call it a 1 by 1 by 1, 10 by 10 by 10, because the angle will remain the same. You could, and I've just called it, because we have to halve it for the midpoint, I'm calling it 2x. You might say, oh, he's bringing in an x. Yeah, but they always cancel. Trust me, they always do. So, if I want to find this angle here, I'm going to need more information. because let's just fill in the triangle ANM. I don't know a great deal about AMN apart from M to N is the height of the cube. But here's the thing, if I knew A to N, we'd have a chance, because that angle there, I'll call it Y. If we knew A to N, then off we go. So let's make a triangle on the floor. So A to B to N, where B is at the right angle. And why do we know all the lengths? Well, we don't know all the lengths necessarily, but we do know A to B is the side of the cube. And we know B to N is half the side of the cube. So we're going to apply Pythagoras, which seems weird when you don't know stuff, but go with it. So the hypotenuse, A to N, is going to be the square root of 2x squared, 2x all squared, which is 4x squared, and x squared. Now obviously that means we get 5x squared. When you root the whole lot, the x comes out the other side because it's root of x squared, but there's a 5 there as well, which obviously you could write as a decimal, but who cares? X root 5 is the length of the line A to N. Let's put it on. Again, looks like it's not going right. Stick with it. So how do we find y in this triangle? That's our opposite. That's our adjacent. It's inverse tan. The opposite is 2x, but watch what happens here. The bottom, the adjacent, is x root 5. Yes, you've guessed it. The x's cancel. You just need to inverse tan 2 over root 5. It wants the answer to one decimal place. My calc said 41.810 and so on. So 1 dp, 41.8. Next. Number 21. Another one. It's more trigonometry, but obviously it's non-right angle this time, so it's sine rule or cosine rule. And it looks like there aren't enough numbers. There are. Trust the process. Just go with it. So it has to be a cosine rule because we don't know an angle on the opposite side. So cosine rule. So as you can see, the labels aren't friendly. So let's call that A. Let's call that C. C. So B. Whoops. Lowercase b. And big B. And little a. So feel free to write it down, copy it down, but it is a squared. So that's x squared equals b squared. That's 25 plus c squared. Don't know it. So that's just a y squared minus 2bc. 2 times 5 times y is 10y cos a. So that's cos 60. But let's just delve into that. We can replace x with y minus 1. And as you can see, it's just a quadratic. Why? Because don't forget what cos 60 is. Sine 30 and cos 60 are a half. That's about to disappear. It's just going to become 5y. So let's expand the left-hand side. I get y squared, square the first, times the 2 together and double it, square the last. Let's tidy up the right-hand side. Y squared plus, and as I've said, cos 60 is a half. So it's simply minus 5y. And oh look, the y's, actually it's not even a quadratic because the y's cancel. Just a matter of finding y now, then we can use it to find the perimeter. So I'm going to add 5y to both sides, subtract 1 from both sides. As you can see, y is 8. Don't rejoice just yet. It wanted the perimeter because the perimeter is k and it says find k. So y is 8, that's this side there. X is 8, take away 1. So it's 5 plus the 8, take away 1, so we've got 7. The perimeter of that triangle is 20. On we go. So when you have a regular hexagon is made up of 6 equilateral triangles, and so will that be. So it's equilateral triangles all over the place. So also, we know A to B like that. That's A. We know B to C. The bit they always like to use, though, is what about that line there, C to D, which obviously is parallel to there, which will also be parallel to there. So if I stick in a little equilateral triangle, that'll help our journey. How do I get from C to D? All right, the way you would get from C to D would be going, let's do A to F. We go with B, because we're parallel, but then against A. So with B and against A. And that's critical to this entire question. That vector there is with B and against A. So positive B minus A. Or if you want to, let's go in the opposite direction. Change the signs, obviously. So it will now be with A against B. So now it wants you to find e to x. There's e, there's x. Let's follow the journey. E to x is e to d first of all. That's parallel and opposite, so that's just A. And then we need to go D to C, which is basically A minus B. And then we need to go C to X, which is basically the same thing. So you can just double it. And believe it or not, simplify it, that's going to be your answer. A plus 2A gives us 3A, and we've got positive 2 times negative B, negative 2B. One that is hard to start up, but becomes pretty easy. Number 23, bit of a doozy. Again, I've done full working out on my worked answers. Here I'm going to skimp a little bit because when I'm writing with this, it's a bit bigger and harder to keep it neat. So, what do you do to find f to the minus 1? You let y equal it. Now I'm going to skip a couple of lines of working out here to make sure I get it all in. So here, what do we need to do? Rearrange to make x the subject. Get x on its own. So let's multiply both sides by x. That's gone. But then let's get rid of the square root. So we square both sides. Now let's take the x squared over. So I get y squared, x squared, minus x squared. And that allows us, as with all these if you want to do transposition of formula and you want to make a letter the subject that there's more than one term of, you're going to have to factorize. So we need to take out the x squared, and we get y squared minus 1. And because I'm running out of room, I'm going to cheat a little bit. Divide both sides by the brackets and square root, which means that goes and that comes in. Now you might say, oh, I've done now. No, you haven't, I'm afraid. Firstly, you've got to flip the x's and the y's. That line should be, need to give myself a bit more room. When you find an inverse function, you need to flip the x's and the y's around. So actually, your inverse function is root of x squared minus 1. And as you can see, what was that statement? It wants you to put it equal to k when you've subbed p in. So let's take ourselves back a few notches. We're going to sub p in and put it equal to k. Now it wants these two to be equal. And here's the logic. The only way that the left-hand side can equal the right-hand side is if it's k over 1. So this bottom must equal 1. So let's square both sides. 1 squared doesn't change. Let's add 1 to both sides. And to find p, we root it. Now, there were alternate methods for that about when you've got an inverse function, your domain becomes your range and so on. But for revision, I think that's a good way of doing it because it reminds you about how to do inverse functions and obviously then using it to solve. A strange one, and yeah, 3 marks is a bit sort of stingy in my opinion. Speaking of which, another stingy 3 marks. So we've got the g of f of a. So let's first of all do the f of a. In other words, take the function and replace x with a. So it was the root of x squared, so that becomes a squared plus k squared. And on the bottom, it was over x. And so our job now is to substitute this into this function. Well, the function just means square it. It's all of x squared. So we're squaring all of that. So to g it, so to speak, we just square it. Yes, I've cheated. I'm saving myself a line of working out. Now, when we square it, the square root on the top disappears. When we square it, we square the bottom as well. And don't forget, we are told that the g of f of a, that's what we've got, is equal to k. So now we need to isolate and make a the subject. So times both sides by a squared. Isolate the a squareds by getting them onto the same side and factorising just like we did for part A. So minus a squared from both sides. Take the a squared out. Create myself a bit of room. Divide both sides by k minus 1. Nearly there, because we want a equals, so we root both sides. So we root the top and we root the bottom. Phew, but we got there in the end. So yeah, some big questions towards the end of that. Some strange ones where it's sort of a lot of algebra, very algebra heavy in the last sort of 4 or 5 questions where not very many numbers were given. Seemed like a running theme in the last 5 or 6 questions. But anyway, I hope that's helped, and I'll see you on the paper 2, maybe.